In this lesson, we're going to look at how to complete dilution calculations. Dilution occurs when we have the same amount of solute, but additional solvent is added. As a result, we see a decrease in the concentration of a solution. When comparing these two beakers, we see that we have the same number of solute particles in both beakers, but the amount of solvent is different. The formula we use in dilution calculations is C1V1 equals C2V2. C1 and V1 stand for the initial concentration and the initial volume. C2V2 stand for the final concentration and the final volume. Any units of concentration can be used as long as the units of C1 and C2 are the same. Likewise, any units of volume can be used as long as the units of V1 and V2 are the same. You may have seen this equation before, written as M1V1 equals M2V2. Because concentrations can be in any unit, using the C1V1 equals C2V2 is preferred. M1V1 implies that the concentration must be in units of molarity, when in fact any concentration can be used. Let's look at an example of how we can use this equation. 1.25 liters of 6.0 molar HCl is diluted to a final volume of 10 liters. What is the final concentration? Note that in the problem we see the word diluted. This is a clue that we're going to be using the dilution formula. We can also see two sets of conditions. We have an initial volume and concentration, and we have a second volume and being asked for the final concentration. We have our equation C1V1 equals C2V2. We know our initial concentration is 6.0 molar. Our initial volume is 1.25 liters. We're trying to find the final concentration, and the final volume is 10 liters. We can multiply 6.0 times 1.25 and get 7.5. Then divide both sides by 10 and get 0.75 molar equals the final concentration. In looking at these answers, we expect to have a lower concentration when we have increased the volume, and we see that 0.75 is definitely less than 6.0. A bottle contains 45 milliliters of 30% by mass H2O2. What will be the final volume if the sample is diluted to 12% by mass? Again, we see the word diluted, letting us know we're dealing with a dilution problem, and we can use the equation C1V1 equals C2V2. Our initial concentration is 30%, and our initial volume is 45 milliliters. Our final concentration is 12%, and our final volume is our unknown that we're solving for. When we do the math, we find that our final volume is 113 milliliters. Note that the concentrations are both in mass percent and my volumes are both in milliliters. Before we look at another example involving the dilution formula, we need to define a couple of terms. The first is non-additive volume. A non-additive volume occurs when the sum of the volumes of the two components do not equal the total volume of the solution. For example, here I have one solution with 4 milliliters, a second solution with 4 milliliters, but when they're combined, they only form 7 milliliters. This is a result of the interactions occurring between the molecules of those two liquids. This doesn't happen frequently, and it often happens when you're dealing with ethanol and water. We are going to make the assumption that we are always dealing with additive volumes. 4 milliliters of one solution plus 4 milliliters of another solution equals 8 milliliters total. In our problems, we will assume that all volumes are additive. Let's look at another example involving the dilution formula. What volume of water should be added to 50 milliliters of 8.0 molar NaOH to make a solution with a concentration of 2.50 molar? The key word here is added. We already have 50 milliliters of solution. We need to know how much additional water we need to add. Again, we're going to start with our dilution formula. We can put in our initial concentration and our initial volume. We know our final concentration is 2.50, and we're going to be solving for our final volume. We find that V2 is equal to 160 milliliters. However, this is the final volume. This is not the amount of water that should be added. To find the volume added, we need to take the final volume minus our initial volume to get the difference and see the amount that's been added. In this case, we have 160 milliliters minus 50 milliliters, and this tells us that we're going to add 110 milliliters. We can do this calculation because we are assuming that the volumes are additive. The 110 milliliters is the amount of volume added to the original 50 to get a total volume of 160 milliliters, which leads to a solution with a concentration of 2.50 molar.